which are the operations which will result in transformed RDDs, while actions are the result which will result in a single result. So in transformation, you will have filter.
Yeah. Like aggregations.
Yeah. So RDD is basically
Relational database. RDD is nothing.
no.
No, resilience
Resilient something.
database.
Resilient distributed
Data frame something.
data sets.
Data set.
Okay,
Yeah.
data sets. So this is RDD. So it is nothing but a data structure, kind of a data structure. Okay. Just
Okay.
like we have different data structure, list, tuple, all these data structures. So this is a data structure which is used for
List of
distributed
tuples.
computing. Distributed
Okay.
computing.
Okay.
So data structure that maintains, we can say, maintains data distributed, okay, across multiple nodes. Okay.
Bro,
So
are you sharing your screen?
oh, okay, sorry. Sorry. Yeah. Sorry. So RDD is resilient distributed data. I was typing. Sorry. Yeah. So this data, it's a data structure. Okay, that maintains data distributed across multiple nodes.
Okay.
So why I'm telling RDD, because Spark relies on RDD. Okay, RDD kind of
Yeah.
data structure. So that's why I'm telling you RDD first. So RDD is a data structure. It's a type of data structure, like we have list, tuples, dictionaries. So it's also a data structure, but it is created for distributed computing. Okay,
Yeah,
so
bro.
that data can be
I heard that. So when we submit a query on top of data frame, in backend
correct.
it will perform as a RDD only. I think,
RDD
right?
only. Correct.
Yeah.
That's why. Correct. So whenever this data frame, what is data frame is actually so data frame basically, like we are using PySpark, right?
Yes.
So first let's complete RDD, then we'll move to that. Yeah. So basically RDDs are first of all it is immutable. Okay. So immutables means read only. So once that is data frame is converted to RDD, right? So in the processing it will not change. Okay. That RDD won't change after it is getting distributed to different nodes, right? So
Yeah, bro. The original value it will be remain same,
yeah.
right?
Okay, yeah, correct. So original records will be same. After that, whatever processing is done, that will be done. Okay.
Yeah. Yes,
Okay.
bro.
So that is read only, and it is a partitioned. Uh, you can say collection of elements. So partition, why partition? Either you can manually mention the partition, like we mentioned, right? Partition based on some column, or we can mention the number of partitions also, or otherwise it
Yeah.
will
Dot
by
partitions.
default. Yeah, by default also it will partition actually. If you don't mention,
Okay.
based on the algorithm which Spark architecture has, it will do the partition, and that's why we are calling it immutable partition collection of elements. Okay.
So that partition, that algorithm does based on the capacity of the nodes, right?
Yeah, correct. Based on the capacity, it will do the
Capacity of
partition.
nodes. Yeah.
Correct. So
Understood.
I was telling it supports two types of operations, right? One is transformations. So first let's complete RDD, then we'll move to and then transformations, and one is actions. So what is the difference between transformations and actions? So transformations include filter. So basically, if transformation means result, uh, in transformation will result in a transformed RDD. Okay. So it will
Yes.
return back an RDD only.
Yeah, bro.
Okay.
Like we'll do transformations like grouping, aggregation,
So
like
like
that.
we have filter. So filter is
Filter.
nothing but a transformation. It will return this thing only, RDD only. Like map
Yeah,
is there.
but it will
Okay.
create DAG only, right, bro? But it will not generate the actual, like it will create a logical plan, but it will not perform those transformations on the real data.
Correct.
When
Correct.
we call the action, then only it will transform. So that's why the query submission is takes less time. But when we call the action like display, insert,
Display. Correct. Correct.
and all, it will take time.
That will take time. Correct. Because
Yeah.
that will result a final result.
Yes, bro.
So this will result in a single result.
Yeah.
So that's why that is still in RDD, right? So that's why that takes less time to return. And
Yeah,
this
bro.
final action will take more time to return. So that
More
is why
time.
I'm
Yeah.
telling, yeah. So like we have count, we have first is there, right? We do first.
Yes. Yes. First.
Collect also is action only. And reduce
Yeah.
also is
Show.
action. Yeah, show is action.
Uh,
Display.
Hello, Srivanaka. Hello, Srivanaka.
Ah, Basha.
Yeah, she's there.
Yeah, Srivani, what there are two types, right? Action and transformation. So when we write a query on data frame on different transformations, grouping and aggregation, so the runtime will be very less, right? Within 0.1 or 1 second.
Yes, yes.
So at the time, what will happen is in the backend, DAG will be there, directed acyclic graph. It will create the logical plan based on our filters and transformations. Just it will create the logical plan. So how to do? Let's say if we need to construct a building, it will just create the plan, but actual work it will not start. So that's why the time will be taken very less, not more than 1 or 2 seconds.
Bro,
But when we call the action,
yeah, correct.
yeah, when we call the action like display, show, count and all, it will take time. Then it will start implementing those transformations on top of the data frame. That will take time. So that is the difference, right,
Okay,
bro?
okay.
Correct,
This
correct.
is called DAG, and it will called lazy evaluation also, we can call it as.
Correct, correct.
Mm-hmm.
Lazy
Yeah.
evaluation. Correct.
Yes.
Uh, so you said DAG, right? Let's say DAG also. Okay, DAG you said. So DAG is, as you said, directed. Am I audible?
Yes,
Yeah,
yes, you
bro.
are audible.
Directed
Okay, okay.
cyclic graph. Yeah.
Acyclic graph, correct, correct. So what is acyclic graph or DAG is? So you can say collection of all the tasks, okay? All the tasks that need to run, uh, comma organized. You can say run organized uh, in a particular, you can say in a particular manner, with relationships. So and dependencies. Uh, yeah, I will explain you with one example. For example, let's say there is one task A, okay, getting input from a data, okay,
Okay.
getting some reading a data from some source, okay. Then
Mm-hmm.
B is writing that or doing some transformations, okay. Let's say notebook task or we are doing some transformation. Then using
Mm-hmm.
this B, we will have one based on this B, right? Once A is successful, then only B will run, right? And once
Correct.
B is successful, then only B, or you can say B. Once B is successful, then we will trigger, let's say, two more tasks, B and C. Okay, C and D. This is C and this is D. So based on this B is success, we are triggering B, C and D, and then if D is successful, then we are triggering E, like that. So you can say uh, now what is this is in a single direction, right? Let's say you are going towards C, okay, A to C. So one of these are nodes. A will be a node, B will be a node, and C will be a node. We can call it like a node of this particular workflow or this graph.
Okay.
Okay, so in a single flow, there will be only one direction. There will be no cycles, which means no path following the directed edges will see a specific node more than once. Okay, so one node you will
Yeah.
see once only in a
Yes,
particular
bro.
direction. Okay, so that's why they are called acyclic, not
Okay.
cyclic, right? It will in a particular direction. If you are going, you will see one task or one
Okay.
node only once.
Okay.
Yeah, I will write it also. So you can call it a set of nodes. Set of nodes that are connected. Because why I am telling, because this is useful in airflow also. So I had learned
Okay.
airflow also long back. So in airflow, this DAG is very much required because we have to visualize DAG. Because there we need to write code instead of creating
Okay.
this visual, right? We have to write code for pipeline.
Okay.
So yeah,
In
airflow when we
Spark,
will
we can say DAG, bro. In Databricks.
Spark Databricks also we can say DAG, correct, correct.
Yeah.
And there are no cycles. So this is also one important point in DAG.
So it will execute node by node. So that means there is no cyclic process. Let's say C will not connect to A
Correct, correct. She will not
and
go
E
back
will
to A,
not connect to A. Yeah. Okay,
which means
understood.
that no path following directed. I'm saying directed because directed means we are going in a particular direction, right?
Yes.
Directed direction sees a node more than once. Okay, so that is what it is.
Yeah.
So yeah, bro. So DAG is like when let's say first you do transformation. Let's say you have one query which will do group by and then find average of some age.
Okay.
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 Let's say you have some new fresher joining in our company, and we want to know the
Okay.
average age of what is the fresher joining in our company. So every
Okay.
year, what is the average age? So you will do group
Okay.
by year, right? Group by year
Yeah.
and
Group
dot
by
average
year.
of age.
Yeah.
Yeah,
Yes.
average of employee age. So this group by, so first what will do, this A node will do the group by, it will do the partitioning, right? Based on the years.
Yes. Yes.
So this A node will distribute to multiple nodes. Let's say you have 4 years, so it will divide into four nodes. Okay. Then B, C, D, like that, it will create. Now in every B, C, D, you will have another action happening, right? After transformation, you will have action. So action will do the final aggregate, okay, after this. So that's how it will divide into DAG, which you are telling that DAG thing is happening in Spark. So Spark has all these inbuilt, like we don't have to create anything manually. So that is what DAG is. So when you will learn Airflow later, maybe in some other company you need to learn Airflow also, then you will get to.
Bro, Airflow is similar to what technology, bro? That is using right now, or it is different?
It's a scheduler tool, a job scheduler.
Scheduler tool.
Yeah, yeah.
Okay, okay.
Like data factory is a very high level scheduler tool. It is a very low, it can take both high level and low level jobs.
Okay.
Yeah.
Okay, understood, bro. So Airflow is independent of any cloud or specific to some cloud, bro? Like AWS or GCP,
No, no, open source.
open source. Okay, okay.
Yeah, Airflow. It's a scheduler tool, okay? And uh, it is used for that same only workflow management. And it is based on DAG, okay? Based on DAG only. So it is also acyclic, okay, acyclic graph. And most important thing is it is written in Python, okay? Using Python code, we will write our schedule.
Okay,
Yeah.
okay.
So how we reach to Spark, you know, right? How did we reach to Spark? Like the history of data engineering.
Mm, no, bro.
Okay, okay.
Think,
Mm,
yeah, don't have idea on that history of Spark.
okay, okay. So data, yeah, bro. So how our trainer used to teach us what is the subject we have? Subject is data engineering, right? Then what is the purpose of the subject? Purpose, then tools and tech used in this subject. Okay. So in this one, we have in schema and also you already know, no need to tell schema. Schema, you know, right? Schema and also you know already. Abstraction, you know, right? Abstraction.
Yeah. Abstraction, no, bro. Hiding of any data.
Correct, correct. Hiding of details.
Yeah,
Yeah,
details.
yeah.
Yeah.
Then
But implementation was I am not no have idea, but theoretical knowledge I have.
okay, okay. So earlier, bro, when we had less data, right?
Yeah.
So we had uh single CPU computers, and we had local file system. Okay, file management system. A file, what we say, file management, right? But which we have this file manager. So then what happened is they started, like there was a requirement to do multi-processing, right? Multi-processing they did. So once this multi-processing started, right? Multi-processing means dividing our jobs or tasks to various multiple cores. Like in our CPU or laptop which we have, there will be multiple cores, right? 8 core RAM, 8 core ROM, like that. Okay. So what happened when data started increasing? They started feeling a requirement to have let's say we have multiple computers attached to a single environment or cluster, and we will distribute these things to multiple things. So then what happened? They came up with idea. There was one first technology is Hadoop. Okay, so should I tell Hadoop or is it useful? Okay, bro. Let's see. Yeah. So one is Hadoop. Okay, and one is MapReduce.
Mhm.
So this is from where we have started. So initially we started with Hadoop and MapReduce. So Hadoop was nothing but a framework. It is like we create framework, right? For coding, we have Flask, we have Django. For coding, we have framework, right? Similarly, it
Mhm.
is also a code. It is also a framework. But this framework is for distributed processing, for parallel processing. Okay. This is
Okay.
also code written in some language. Let's say Spark is written in Java, right?
Yeah.
So similarly, Hadoop is also written. Hadoop and MapReduce both are framework actually. This is based on Java. Okay, MapReduce. So it's a processing technique, program model for distributed computing. I will tell you why. I will tell you the advantage of Spark. Why? Because people will ask you the advantage of Spark. So what will happen is in Hadoop MapReduce, uh, it will try to write, it will do the operation, but will write there was some expensive writing happening in ROM. Okay. So in our computer, we know, right? RAM is there and ROM is there. Okay.
Yeah, bro.
So ROM will require writing the data to disk. Okay. So this
Yeah, like
map
hard
reduce
drive.
hard drive, yeah. So this
Yeah.
map reduce was using was requiring to write the data in ROM first. Then it was doing the processing. It was
Okay.
using ROM. While what
Okay.
happened is this writing to ROM is expensive. It will take time. There are chances of crashing also. Okay, corruption also sometimes, because many
Okay.
times cluster in different cluster when you're writing the data. So it depends on the hardware. We are dependent on hardware too much, right?
Yeah. Yeah. Yes, bro.
So what happened is Spark came. Okay, what Spark did, instead of writing the data to ROM, it started using RAM.
Okay. So
Okay,
that's why,
so
bro,
that's why it becomes
Spark is
100.
called as in-memory
Yeah,
processing.
correct, correct. In memory
Okay.
processing.
Hadoop
Yeah,
is disk processing, right?
yeah, disk processing,
Yeah.
map
Now
reduce
I
Hadoop.
got to know the backend reason, bro. How they call
Yeah,
like that.
that's why it is 100x faster, they claimed earlier. Now they have removed it from their website, but it was 100x faster. Okay, and how they used
Okay.
to query, right, using Hive. Not give, it's Hive. Okay, Hive. So like we have local file, right? I will tell you what is HDFS is Hadoop distributed file system. It is similar to local system. Okay, HDFS is nothing but similar to our local file system. This was Hadoop distributed file system. Now in Spark we have DBFS. Okay, Databricks
Okay.
file. What is DBFS? DB Databricks file system in
File
Spark.
storage system. Oh, yeah. Yeah.
Yeah. So earlier this was used HDFS in Hadoop.
Okay.
So Hive will allow us to query the data in SQL manner. Okay. Nothing, that's it, bro. That
Okay.
is what Hive is giving us. That so in this so the data is distributed in different machines. Okay, different cluster, different in a cluster in different machine, you can say. So
Okay.
Hive will allow us to query the data in SQL using SQL manner on this HDFS. So
Okay.
Hive is a framework created on top of Hadoop, which will allow us to query the data. Okay, and MapReduce is for transformation processing tool. It's
Bro, this
a
Hive I didn't get, bro. So let's say, is it not available in Spark? Hive?
uh, okay. Let me give. So Hive is a software, okay,
Okay.
under Hadoop umbrella.
Okay.
Okay. So
Okay.
uh, so it is kind of a layer on top of Hadoop. Okay, that makes data queryable.
Okay. Okay. Hadoop data we can query using Hive.
Yeah.
Okay.
So that's why I call, right, Hive table. In Databricks, we are calling
Yeah.
them Hive table.
Yeah.
Why? Because yeah. So why? Because these tables, right, are distributed in file system, are using distributed file system, right, which we are having in our these tables, bro. IMP dev, IMP
Yeah. Yeah.
prod tables
Those
in
are Hive
Databricks.
tables only, right, bro?
Correct. Because we are
Okay.
able to
Okay.
query,
Understand.
right? They are on
Query.
distributed
Yeah. Yeah.
system. They are on distributed system, but we are able to query.
Okay.
Okay, yeah. So it gives us a SQLite interface. SQL-like interface. Okay. So it is who has developed this Hive. So it is developed by Facebook. Yeah, now maintained by Apache.
No, bro. Okay.
Yeah, bro. I was also
Okay.
yeah. Even bro, Spotify has developed one technology. Spotify Luigi. Like we have Airflow, right?
Yeah, bro. Airflow scheduling jobs.
Yeah, like we have Airflow, there is Apache. Sorry, there is this Spotify Luigi.
Spotify.
So in memory, you were saying, right? In memory processing. So that's why faster than MapReduce. MapReduce. So MapReduce has one shortcoming, limitation, that it will rely on expensive, uh, you can say expensive data writing on disk. Okay. So Spark has overcome that shortcoming. That's why we are using Spark. And this PySpark, right? It's this thing, bro. It's so it's a API. So when it's a programming Python programming interface. Like we have other program interface also. Interface is nothing API only. Okay. It's a Python API. Okay.
Okay, bro.
So basically this like we have get, post and all functions, right? In API. We have here also read, write, options. These are API parameters, API functions.
Okay.
Okay. So this PySpark is a API. And on this API, we have this function like we have get post. Okay. Like get post in PySpark. We have these functions. Okay. API functions. So this is about PySpark. So what is one more thing of PySpark is, so PySpark uses data frame abstraction. Data frame frame abstraction like pandas. While Hive, what was Hive using? It was using SQL like interface. Okay. So this Hive is also similar to, let's now you can compare, right? Spark is similar to Hadoop. Okay. Hadoop. Okay.
Okay.
Spark has the functionality of Hadoop and MapReduce both. Okay. Distributed computing also, and
And
processing technique both are
processing.
integrated. Hadoop and
Yeah.
MapReduce are integrated in Spark. And Hive
Okay.
is like what we have like PySpark or Scala or some API. So
Okay.
similar to Hive, we have this. Okay. PySpark and Scala. So in Hive, we will use SQL like interface, and in PySpark, we will use data frame like pandas interface. Okay. So that's what the analogy is. In short, I have tried to explain. So first we RDD, RDD is resilient data distributed data set. So this we have done. DAG, Airflow, PySpark. Yeah. So before PySpark, I jumped to unnecessary things, but yeah, Hadoop, Hive, Spark. So this is one important point actually, that MapReduce had one limitation, that it will do writing on disk, while Spark is using RAM, so it is in memory.
Yeah.
So that's why it is faster.
Yeah,
It is
bro.
doing all the processing in the RAM only.
Bro, I have one doubt. So the layer which is created on top of Hadoop is Hive. So which can
Correct.
carry the Hive tables
Hmm.
which are created using Hadoop framework. So
Correct.
similarly, is there any layer on top of Spark that we can query those tables, bro? Is it Hive Metasphere?
Hive Metastore?
Similarly, like do you have some layer right to fetch the data?
Hive.
Yeah. Similarly, for Spark, is there any layer or is it Hive only? That's
Yeah, we
my
have
doubt, bro.
Hive. Yeah, Hive SQL we had right there. So
Yeah,
here
Hive.
we have they have a Hive, like we have there they had Hive SQL, we have PySpark, Scala and all, right? So they have created an API over that top of Spark.
Yeah.
So on top of Spark, this API is there.
On
Okay,
top of
so
Spark API. Yeah.
API is there. Spark, PySpark or Scala. Many other languages are there. Like Scala is there, bro. R is there.
Yeah.
Even yeah, Spark SQL is also there actually. We do Spark.SQL, right?
Yeah. Yes, bro.
So in Spark we have many options. PySpark we can use Scala or even SQL also. So similar to that only.
Yeah.
There that interface for only SQL, Hive SQL.
Okay. Only in SQL queries you can run in Hive,
We
bro.
can run. Correct.
Okay.
That's
Spark
why
will not support.
no.
Okay.
PySpark was not in history
Okay.
earlier. Yeah.
Okay.
So it is a new thing.
Okay, bro. Understood.
Yeah. Yeah, I'm not going into technical, but first today I explained this history and some terms. That's it.
Yeah. Yeah, this much is enough, bro. So I will go through once this, and if I
Yeah.
have any questions in tomorrow session, I will ask, bro.
Sure. Actually, we had
Yeah,
to
bro.
do hands-on all on this. We have done hands-on
Yeah.
also on this Hive and all. We have done hands-on. So if you
Yeah, Hive
see,
nothing but we are pulling the table using SQL, something like that. So is this the one,
correct,
bro? Hive hands-on?
cor- correct. I will show you hands-on. I keep all my project here only, not to. So here, see, this is batch time analysis. This is using AWS, log data, social blog. So I think this is Hive only. Let's check. Yeah, this is Hive. So here you see I'm doing all the things I'm doing using SQL. See, create table, Hive, see Hive. Okay. Hive create database, use VDHS. Okay. So I'm giving Hive only, but it is SQL like.
Yeah.
Okay. Create a data pipeline using Scoop to pull the data from table
Okay,
below
okay.
using my SQL server into Hive. So this is all Hive only.
SQL. Okay.
So we are using SQL, you can see. So it is all in
Okay.
that black interface. So this is count of number of records. See, I
Okay,
have
like
given
command
the
prompt.
yes. Using command prompt, we do Hive query
Okay.
and so table name user import connect. This is the command just to connect the table. Uh, so create table, Hive table. We have to first create the tables. So this is the create table, and then you can see select star. Okay, we are doing SQL only everywhere. Select
Okay.
star from stock out, stock joined info limit 10. Display 10 record. Now to display the top 5 company, we are giving again same query we are giving. By running this query, use this, create, select, group by. So query only I gave. And there is this interface they created for Hue. Hue is an interface, bro. So like you can do from command also, like this in black command, or
Yeah.
you can do from Hue also. So Hue they had later created one
Okay.
interface called Hue. So it's like
Like
SSMS.
studio, bro.
Yeah,
Yeah.
studio. It is a studio for distributed Hive computing. For
Okay.
Hive only, it is basically. So you can see
Okay.
Hive
Okay.
is written with here. So you can see, or I'm doing SQL only. And
Okay.
you can see in the background, it is running MapReduce, right? MapReduce CPU time
Yeah.
spent.
Yeah.
So
That
yeah,
means disk processing.
yeah, processing.
Okay.
So this is the hands-on. Basically, it is nothing like similar to SQL only. See, select and all I'm doing query. It is just like SQL only, SQL Server or Azure SQL, but for distributed computing. Means data is stored in different computers. That's it.
Okay.
Yeah. So Hive was there for Hadoop. Now we are using Spark. So for Spark, we have many options: PySpark, SQL, Scala, or
Yeah.
anything. Okay, so it is using Pandas data frame extraction, while this was using SQL only. So this is that thing. So once,
Okay.
yeah, so this is the thing, bro. If you see code wise, everything is same. Like we create only some commands are there to connect with the machine. That's it.
Okay.
Yeah. So the master node we are connecting using some command. I think
Okay.
some command we are giving. Yeah. This so I also forgot in depth.